So here's what I want to do in terms of how we construct this time-based blind SQL injection attack. First thing is, I want to go and find another vehicle I can vote on, because once I've voted on one, I can't vote again. So we'll go back to the leaderboard, and I'll jump down to, say, the Mercedes-Benz. Let's go there. Okay, so now we can go into vote again. Now, ultimately, what we're going to want to do here is manipulate this query. And it's very hard to manipulate a query like this in the browser. So this is actually an asynchronous post request. So what I want to do is actually capture that request when the vote is made, and then we'll manipulate that request and reissue it. Now the way I'm going to do that is with Telerik's Fiddler. So let me jump over there now. So here we are in Fiddler. And really, you could use any tool at all that allows you to reconstruct HTTP requests. The reason I'm using Fiddler is that it's very easy to capture the request, manipulate it in the composer, and then reissue it. And if Fiddler is something that's new to you, go and check out my Hack Yourself First course, where I give a pretty good intro to it in terms of what it does in scenarios like this. So Fiddler is now running. It's going to capture the request that we make when we vote for that Mercedes-Benz. So let's jump back over to the browser. And in fact, I'll even just snap the browser over to the right-hand side of the screen so we can see the request in the background. Now this time we'll keep it simple. I'll just put in a comment called foo. Let's now issue that vote. And in the background, we can see the request. Now a couple of things to note here in this request. So first of all, if we look at the request headers over to the right, you can see that it is posting to /API/vote. I've mentioned multiple times throughout this course that the HTTP verb has no consequence on the vulnerability to SQL injection. So whether it's get or post, or even something like delete or put, the same vulnerability exists. The big difference with things that are not a GET request though, is it makes it a little bit harder to just reconstruct in the browser. Regardless, it's easy when you can construct the request in a tool like Fiddler. Now the other thing we'll look at is if I go down and look at the response, and I look at the raw response, there is no response body. All we're seeing here is response headers. So this goes to the point earlier on, where it's trickier to use something like a union-based injection, or even a blind Boolean injection, when there's no actual response body to look at. Now one option here would be to explore an error-based injection, or another vector which changes the response code of this particular request. But what we're going to do here is use that blind time-based injection attack. So let's do this. I'm going to jump on over to the composer, and I'm going to drag this request over to there now. And what I want to do is inject in down the bottom just here. So we can see here in the request body, our comments equals foo. Let's go and grab Notepad and the query that we constructed a little bit earlier on in the Boolean-based injection. So here it is, and that worked well in the context of the order by clause. So this is when we used a case statement to either order by power kW if true, otherwise top speed km if false. We can't order anymore in this particular attack. But what we can always do is close off the existing SQL statement and then inject our wait for delay clause. So the first thing we've got to do when looking at this statement is figuring out what's the right syntax in order to drop this in after foo in the comments. Now inevitably we're voting here. So we're actually going to be creating a record. This is going to be doing an insert into a table. And as we saw earlier on in the course when we looked at those SQL syntax fundamentals, this is inevitably going to adhere to a syntax such as insert into table name, followed by column names, and then values. And the values is a comma delimited array inside a set of brackets. So here's what I'm going to do. Let's just take a new line up here, and let's imagine what happens after foo. I'm going to close off the foo string, I'm going to close off the bracket at the end of values, and then I'm going to terminate the statement. So this should now give us some clean air to write our injection attack. Now this time I'm going to use an if statement, and it's simply going to look like this. We're going to write if, and then the condition, which will be everything in brackets over here, the equivalency, which will be the less than or equal to 109, and then I'm going to take out the remainder of that old case statement. So that'll be everything from the end all the way through to the then clause. So here is where I want to put my wait for delay. And just like before, we will give it a delay of 5 seconds. And then just to make sure that any remaining syntax that would have appeared after foo in the request body below doesn't actually get executed and inevitably cause a failure because it wouldn't be syntactically valid, we'll use the old comment syntax, just like that. So recapping, this line here should close off the insert statement, check to see whether the first character of the first record in the name column of sys.tables is less than or equal to M, and if it is, it's going to wait for 5 seconds. If it's not, it's going to respond immediately. So let's copy that onto the clipboard, and we'll now drop that down into the composer right here. And we can now just execute this request. Now that responded pretty quickly. So let's check for the inverse. Let's go down here and change less than or equals to greater than. And we'll execute that. Now it's waiting. This hasn't responded immediately. We can see a delay. And there is the response. So the time-based injection attack has just given us two very different answers, depending on whether we're looking for a letter less than or equal to M or greater than M. Now we know from the earlier attack that we did using Boolean-based blind injection that the first letter of the first table in sys.tables is actually a W. So this reconciles with that other test. Now just to be sure about durations, let's go and click the first request we did over here. We'll look at statistics, and here we can see an overall elapsed time of 0.76 seconds. We look at the second request, and here's an overall elapsed time of 5.29 seconds. Now, one thing about a time-based SQL injection attack is figuring out what is the right wait for delay duration, because 5 seconds is quite long. And in reality, we could probably get away with only about 1 second. It would certainly allow us to mount the attack at a much faster rate rather than waiting an extra 5 seconds every time we got a true result. But of course, the trick here is not getting false positives, because the very nature of the internet is that sometimes we're going to have randomness in our response times. So you wouldn't want to have such a small value that you're not sure whether you actually got a true or a false answer, but you don't want to have such a large value that it's going to take a long time. The right figure is something you can establish by ascertaining how reliable the connection is. So issue a bunch of requests, what sort of range are the response times, and then making sure the wait for delay period is sufficiently large that you'll always be able to know when it's that condition that's been hit. Now again, as I said when we talked about Boolean-based blind SQL injection, this is laborious and it's repetitive. In fact, it's even more laborious because you've got to wait for these durations. And it's exactly the sort of thing that benefits greatly from automation. And as I've said multiple times throughout the course, we are going to look at automation later on. But this was important for you to understand the underlying mechanics of how a time-based blind injection works.